Okay, this is part 3 of our lecture video series for Monday, March 6th, where we move away from the Lewis model of bonding and into bonding models that account for the quantum mechanical nature of electrons. And the first of those models is one known as valence bond theory. So let's remind ourselves about why I'm making you learn this stuff. So in the Lewis model, electrons are treated purely as particles that are either gained, lost, or shared. And we know that this treatment of electrons as purely particles is not quite correct. So this is not the whole story. What we know is more true about electrons is that electrons are defined by their wave function and resulting from mathematics done on that wave function, like the Schrodinger wave equation and taking the square of psi and integrating it. Again, quantum mechanical math you don't need to know. We get this idea that electrons being found in quantized energy levels of our probability maps. In other words, electrons live in orbitals. So if we know that according to quantum mechanics that electrons are better described by like the electron configuration, their set of quantum numbers, what orbital they're found in, what energy level, etc., then the Lewis model starts to fall apart because it ignores the inherent wave-like nature of electrons and instead focuses purely on just the particle-like nature of electrons. So let's define a chemical bond as a result of our first kind of quantum incorporating bonding model called valence bond theory. So according to valence bond theory, we're talking about a covalent chemical bond. What we're talking about is not necessarily like electrons that are being shared, but rather some kind of overlap that's going on with the orbitals that contain that electrons. So in valence bond theory, a chemical bond is described as a region of orbital overlap such that half-filled atomic orbitals, just meaning half-filled orbitals on atoms, overlap to create a spin-paired bonding pair of electrons in the overlap region. So what on earth am I talking about here? Let's look back at H2. So recall, each hydrogen atom has the electron configuration 1s1. So if I were going to look at two hydrogen atoms in the Lewis model, I would draw them like this. But in the quantum model, I would need to, in fact, treat like a little dot as showing where my nucleus is, and then represent this 1s orbital as a sphere around each of these electrons. And if I were to think about like the orbital box diagram of each of these, if they're 1s1, then they are each full or half full with a spin up electron. So this is kind of our quantum representation of what's going on. So then in valence bond theory, VBT, the molecule H2, well, let's do Lewis first. So in Lewis, H2 would look like this, but in valence bond theory, what we see is instead is an orbital overlap such that half-filled atomic orbitals overlap to create a spin-paired bonding pair in that overlapping region. So if I were to kind of push these s orbitals together until they created a region that was overlapped sufficiently so that we are overcoming the negative repulsion of electrons, but yet also following the positive attraction between our electrons and protons, and also the repulsion of the nucleus, right? It's kind of like if we had to smash these together to just the right degree of smashing, we would probably see something like this, where in this overlap region here, this is where we would find a spin-paired bonding pair, which is the result of these two spin-up electrons coming together, and in that overlap region, forming a spin pair. So this is the Lewis model, and this is valence bond theory, saying, hey, we can't just ignore the fact that electrons are quantum mechanical particles. So in our next video, what we're going to do is we are going to think about kind of the results that arise when looking at valence bond theory for atoms that are a little bit more complex than hydrogen, right? Hydrogen just had that 1s orbital. Here we're going to look up next into this concept of atomic orbital hybridization. So it's still a facet of valence bond theory, where again, valence bond theory says that a covalent chemical bond is the result of an overlapping atomic orbital such that that overlapping atomic orbital is half full, and the overlap resulting from the bond being formed creates a bonding pair that is spin paired. We're going to look at what atoms do in order to achieve this according to valence bond theory, and then I think that will be all for today.